back at the end of last year's Sinclair-themed charity event, the lovely Chris Cathers, who you can often find lurking in the RMC Retro Museum as a volunteer, whispered in my ear at the kitchen serving hatch that he might have something very special to donate for next year's charity event. At the time, I hadn't even started thinking about the next event. I'd not even decided what the theme would be. But when Chris told me what he had to offer, I knew this year we had to go Commodore. A few months ago, on another visit to the cave, I met up with Chris once again, and he handed me a big brown box. On other subsequent meetings, he also handed me some smaller boxes to go with the big brown box. But we'll get into those later. The big brown box contains a Checkmate 1500 Plus, which is something I never even dreamed I'd see on my channel. And once I've filled it up with various bits of Amiga, I'm going to put this whole computer up for auction to raise money for an amazing charity called the Befriending Scheme. More on that at the end of the video. I better open this box. To show how a pro goes about their business, here's Neil unboxing the first Checkmate 1500 Plus to roll off the production line. That man knows how to unbox. Let's see how I get on. The following old man noises may disturb small children and timid animals.
Oh my God.
Please do not adjust your set. Normal old man noises will resume shortly.
No. Ow. Oh.
Poor old boy. There are a couple of other brown boxes inside the big brown box. One contains some metal risers and the other contains a chassis for the keyboard. There's also a beautifully presented manual I've greatly enjoyed reading, probably as much as any manual I've ever read. Not that I read many of them, as I'm usually one for working things out myself, but this one is just so nice. I read it for fun. This case was bought with the specific intention of filling its insides up with an Amiga 1200, with a special backplate to fit most of the 1200's external connectors. But as we all know, Amiga 1200s are expensive these days, one of the more sought after machines to relive your Amiga nostalgia. I put the problem to my amazing supporters on Discord. You can join in if you like, the link is in the description. And we jointly decided to purchase one and raise the money to pay for it via my Ko-fi page. A rough target was set and funds began to accumulate. I put out some feelers for a good value A1200 fixer-upper, and then out of the blue I got an email from a nice man called Andrew Searle. Andrew heard of my need for an A1200 and kindly offered to donate one to the cause. He even drove it all the way from the other side of the country and dropped it off in person, along with a bunch of other goodies like this A600 and this A500 Mini, both of which will be in the auctions. By the way, the unneeded funds raised for the 1200 were used to buy the mini pet I recently built, which is also going up for sale. The Amiga 1200 that Andrew handed over is actually in marvellous condition. It's almost a shame to remove it from its case. By the way, after the main auction day on the 19th of October, I'll be selling off all of the other bits and pieces I've not had time to get ready for the big day, including this case. Oh, and this case too that Yawning Angel Keith gave for the auctions. Inside the 1200 case is a fully equipped machine in very good condition, with a compact flash hard drive, Kickstart 3.2.2 ROMs, and an 8MB trapdoor expansion. Peering down here at the caps, it doesn't appear to be suffering leakage or any corrosion. It's very possible corrosion can be going on underneath these caps, and even if it isn't yet, they will soon fail. So I'm going to change them for something that won't ever leak again. Switching on the machine is in perfect working order. I took the opportunity to run through all of the tests in Amiga Test Kit and it passed everything, including the keyboard. The only thing I'm not 100% sure about is the floppy drive. Benchley has some thoughts.
I don't know if I'm going to be using the floppy drive from this yet. That's to be decided. I'm not sure if this is working. I did some initial testing of the whole computer and this didn't format a disk properly. It could have been the disk, but I'll need to find out if that's going to be the way to go. It might be a Gotek, and I have got a spare Amiga 1200 drive from my own that I can put in here if needed. No problems on the backside. There is a bug walking around in there. Go live somewhere else. No discoloured caps that I can see. No burn marks on the decoupling caps. It all looks good to me. So I bought a set of caps from Retro Passion for this, and I thought I'd go the extra mile. And I bought the deluxe set, and these are all polymer caps. And polymer caps have no electrolytic fluid in them. It's a gel instead, I believe. So they can't leak. These will hopefully last forever. Even the through holes are polymer. First a splash of fresh solder. Pretty good condition too. Now I've got to get these things out, and the tip of my desoldering gun won't go over them. This is the larger one I have, and yeah, that doesn't fit over the. This does a pretty good job. Right, all of the pads are intact. I think I got lucky with this one. I did pull that a bit too urgently and I didn't wait for the solder to melt on the other side. I thought that the tabs were holding on and you know, where they were bent into the holes, but it wasn't that. It was actually the solder. I needed to wait for the solder to melt a bit more. So now I need to cover up any other plastic bits like these. And this bit needs to be covered, and these need to be covered with some marvellous aluminium foil tape.
I've said many times before that the hardest caps to deal with in an Amiga 1200 or indeed an Amiga 600 are the through-hole caps. The motherboard on these machines contain heavy swathes of copper ground planes which suck the heat right out of the tip of your soldering iron. Unless you have pro-level equipment, you'll struggle to make solder melt all the way through the board. My Hakko iron is what I would consider a high-level enthusiast tool, and it completely fails to do the job with these boards. The temptation here is to whack the heat up high and pump some more power into the issue. That can work. Where you can get caught out is if you forget to turn your heat back down when heating the other leg of the cap. I've done this and had the through-hole plating just melt off the board. It's not too difficult to repair, but it would be better not to have to. To get around this issue and to give your soldering iron a chance, it's a good idea to preheat the area with hot air. That raises the surrounding board temperature and means that not so much energy is taken from your iron. Since I started doing it this way, I've had no problems at all. The caps around the modulator area are especially difficult, but even these just fall right out when I preheat. What's on my tip? Right, that's all the through holes out of the way. Now, after taking lots of photos of the cap positions and values, it's time to remove all of the surface mounted caps. Before I do, I need to protect the delicate plastic parts from the hot air I'll be using.
Yeah.
I made a short video recently on my new method, but basically the way I found works best for me and causes the least amount of problems is to pierce the top of the canister to prevent pressure building up and take the caps off with hot air. Let's whiz through these quickly. It's really satisfying taking them off this way, and it appears there was no damage caused. But just to make sure, I'm flowing solder onto every pad before removing it with solder braid. Before I got a bit bored of doing it that way and then switched to my desoldering gun.
This is the end result. They look fine underneath, but the tops are all covered in their own guts. And it's sticky and not very pleasant. I'm going to say that that was a highly successful experiment. I'm sticking with this method now. Next up, recapping with polymers. Never done it before.
Whilst my method of removing SMD electrolytic caps has changed a lot since I started, the way I put them back on has stayed pretty much the same for a long time. One method is to put some solder on one pad and then melt that and slide the cap into place. I much prefer to get the cap in place, add flux, then add some solder to the tip of my iron and use that to solder the first pad. Both methods work well.
Boy, there's not a lot of room here. You lot are in the way. I forgive you, don't worry. Let's do this awkward one here next, because I want to work on the easy side first. And with this one being so tight up against that PCM-CIA connector, I want to make this as close to this end as I can so I can get the soldering iron in there without risking melting that connector. And this is where a hook nose comes in, really handy. Good, huh? So we've got one more here, the through holes obviously, and then some more on the other side of the board. So let's get this one in. Can't get exactly the right amount. Well, not exactly the right amount, but not too much and not too little. Without the through holes in here in the way, I'm just going to give everything a quick hoover up to get rid of any of that flux that is still hanging around. Nice. So I could use the MG Chemicals, you know, flux pasty stuff, not paste, but the goopy stuff I use for SMD stuff. But that would do a better job. for sure that would do a better job of soldering these points, but it would be a nightmare to clean off afterwards. This stuff just dissolves. Well, most of it burns away. Most of it burns away when you heat the joint. It's just gone. It's mostly IPA, and whatever's left is easy to clean off. It has its downsides, but for this it's really good. Careful with this stuff. It's very sticky. It's quite easy to pull off components. Just checking underneath to make sure I haven't. I purposely didn't push it down on this side. It's naturally got stuck down a bit from me leaning on it. No melted plastic at all. That might be a first for me. Wonderful. And there's two 10 microfarad caps left over from the kit.
Great, now all of the SMD caps are installed, I'll just put all of the through holes in. Again, this isn't as easy as you might expect with the heavy ground plane causing the solder to freeze before it makes a good joint. More hot air sorts this out.
That's not soldered. Need a better tip. This is my normal tip. Come back. And I'm going to try this one. Chonky. Never used it before. Try that again. And this time I'm going to use a little bit of flux. And my new chonky iron. This thing is massive. That's still not soldering. So, yep. There he goes. This one might give me some trouble as well. Yeah, the trouble with this iron is it's not actually touching or transferring heat into that tiny pad. The solder's just going up into the massive great end of the tip. I'd be better off with a smaller tip here. Because all I'm doing now is cooking the capacitor. Right, so something else I can do. Right, got the smaller tip on. Let's give it some heat. They're still not going. They're sitting in a peak above it. Oh God, what's going on? Crank the heat up to 420 on the soldering iron. That's it. Perfect. We move on. Last two. This one. Right, just going to turn my heat down because these pads are actually quite easy to lift out with too much heat. Right. So I need to put the connector back and those. Might have to leave the blue tack in there. Right, 360 for these outside ones should be absolutely fine. I'm going to crank the heat up to 420 and preheat the board. Perfect.
Right, with those connectors back in place, I can give it a test before we move on to installing this board into that lovely case.
Still works. Nice. Oh, smooth. That being the correct way to do it, Neil.
At the front of the case is an LED board and two panels where various drives and peripherals can be mounted on this shelf, which can be taken out by removing a couple of screws underneath. The wire on the left is for the power switch. The first job is putting the motherboard in place and working out which mounting points will be used. There's only a couple of holes in the 1200 motherboard, which limits how many points it will be attached to. It does mean it flops around a bit at the back, but that gets sorted out in a bit.
Okay, so the power thing.
Now with the board fixed in place, I can attach this power adapter. Normally the Amiga 1200 is powered from an external brick. This board takes the power points back inside. I'll need to cover this later with something to prevent accidental shorts. The other end attaches to this power board inside the case, and this is then powered by the internal mini SFX power supply.
I like it. Shouldn't interfere with the PCMCIA slot.
Oh dear, I forgot to attach the mouse port to the side of the motherboard.
Oh, will that go in? No. No, let's take it out. I mean, I'll take that out as well. Oh, God. Probably.
Just loosening the screws up is enough to let me wiggle it into place. Chris gave me all the bits I would need, mostly, to build this complete, machine, including this posh SFX power supply. I'm screwing it in place now, but it'll need to come out again as it blocks not only the floppy connector, but the whole of the trapdoor area. So with the power supply connected and the power switch plugged in, it's time to switch this on and see if I've broken anything. The fan in the power supply is spinning. It's very quiet though. And I have no LEDs on the front panel to show if it's working or not. No floppy drive installed, so it will take a little while to boot. Nice, a working machine so far. What's next?
This is the state of play. I turned the camera off and had a little play around. I've taken the power supply out and I've taken this shelf out as well. Now the problem that I found is that the Amiga 1200 floppy drive, this one, if that's sitting on this shelf at the right height, at the normal height, it doesn't actually fit into the front panel properly. There's probably a 5mm gap, I'd say. And I did think about using washers to stand it up off of the shelf to put it at the right height, but the problem there is that it was really difficult to do that because you've got to get stacks of washers on each one of these, then get this shelf on here and put all the screws through, and it's just a massive pain. I could do that. The other thing I thought about doing was actually putting some washers underneath here to stand this up a little bit as well, so I could put a couple of washers under here and maybe a couple of washers on the top here to get it up there. So what I've decided to do is, instead of using an Amiga 1200 drive, I'm going to use this Amiga 500 drive, which I've cleaned up as best I can. And this one actually, with the case in the right place, just sits in exactly the right place. And I think looks just as good. Right, so the other problem I had is if the floppy drive is here, like so, just wedge that in. The floppy drive is there. This is the longer cable that Chris gave me. It won't reach. So I've got some ribbon cable and I've salvaged some ends of floppy cables. Yeah. I just need to cut this down to the right length and the right width, clamp these on the end and make a cable that actually will fit.
I made a nice long floppy cable and here you can see me fitting it the wrong way around. Don't worry though, I'll sort that later. To make this a bit more special than a stock Amiga 1200, Chris also donated a PiStorm32 Lite, which needs a little bit of assembly before I can install it. I really like the way this goes together. It's an amazing piece of design by Claude Schwartz and the PiStorm team. I especially love the way you can use a full Raspberry Pi 3B with all of its ports intact. It took me a few moments to realise that the Pi connects to the GPIO from the other side. So clever! The PiStorm board also acts as a heatsink with a thermal interface pad sitting between the two boards. When installed in a normal 1200 case, there's a danger of the back of the keyboard shorting out the GPIO pins, which is why this white plastic part is included as an insulator. It's not needed here, but I'll install it anyway. Okay, now to put it all together. I'll need a way to break out the different internal connections. I want an SD card for this internal IDE to be accessible from the outside of the case, as well as the one in the PiStorm. I'll also need the USB for the PiStorm extended out of the back, and this USB keyboard adapter, also supplied by Chris, will need an external socket. I'll install the PiStorm now so everything is in place. It's the easiest of the PiStorms to fit. No messing around with replacing CPUs. Just slot it into the edge connector here. There isn't much support for it though, and the USB ports will bang against this standoff, which I don't like very much. So I quickly 3D printed a sleeve to go over the standoff to hold the PiStorm at a better angle and hopefully stop it slopping about. That's much better. If it's not wiggling around, it's less likely to work its way loose. Yes, HDMI. I could run a long cable out of the back of the machine and that would work, but it would also look terrible and that isn't what we're here for. So I designed this. The center section is for HDMI and the two boxes will house these SD card extenders. I went through a few iterations of this design and just need to remove some supports before I can get it installed. That's ready to go into the case. Next I need the two USB ports. I have to give some credit to Fuzzy for this idea as he was here when we figured out the best way to do this. In the kit Chris gave me was a panel mount USB port, but there's nowhere to mount it on the back of this Checkmate case. In my PC parts bin I found this back panel plate with two USB ports. Originally it terminated into a double row block connector, but I took that off and split the ends into a single row connectors. One to go into the USB keyboard adapter, and the other one I turned into a male USB to go into the Raspberry Pi. Next the Pi. Oh dear, there isn't enough room to get the USB plugged into the Pi. Later I figured out I could just remove the PiStorm, plug the USB in place and then put the PiStorm back. It's a tight squeeze and not ideal. Instead I purchased a right angle adapter and fitted it. It makes a much neater job. And with this panel installed, I have all of the ports extended and accessible to the back of the case. Now if you want to run the PiStorm, you can remove the internal IDE SD card, and if you just want to run stock A1200, you can remove the PiStorm card. Interestingly, leaving them both in the machine boots the internal IDE first, but with the PiStorm still active. This then gives you access to all of the storage on the PiStorm and the internal drive. It does make a bit of a mess of the drive mappings though. If this were to be my machine, I'd spend days setting this up to my own liking. But it's not. It will belong to one of you soon, and you can have the fun of getting all of this sorted out how you want it. Right, that's all tested and working great. The last job is the keyboard. This is a keyrar, which is an amazing device that converts many different vintage computer keyboards to USB. I test fitted this inside the new keyboard case, and these pins along with the front here are much too close to the metal underside of the A1200 keyboard, so I'm just going to remove them. With the keyboard built, all I need to do is connect a normal USB A to B cable to the keyrar and then plug that into the new USB socket I've marked on the back of the Checkmate case. For the PiStorm, I have a ready-made image here, but Chris has posted an SD card for me to include with this, and that should be here in a few days. For now, I can try out a few favourite games and run sysinfo and marvel at a score that puts this machine at 607 times the speed of a stock 1200. Complete madness! Much as I'd like to spend a few weeks getting all of the software side of things set up for the eventual owner, I don't want to spoil all the fun for them. I'll get this photographed for the listing and then box it up, ready to be sent out. Included will be this tank mouse. I'll take out the very clicky buttons and replace them with a couple of Omron switches to turn this into a very nice mouse. Also part of the package is an external Gotek floppy disk drive, which Colcuz donated. A nice addition. And that's the last machine to be built or repaired for the auctions. All I need to do now is get all of the machines listed on eBay so people can start bidding on them. On the big day itself, there will be around 26 special guests joining me from 11 AM until 11 PM British summertime. None of this quiet one-on-one calm and friendly chatting. No, this year we're embracing the chaos. Some of the guests I invited were booked to go to events on that day, but were so amazing they've offered to drop in from those events. I don't want to spoil anything yet, as it could still not happen depending on technology out in the field, so to speak. But it could be a lot of fun to see how it unfolds. Well, that really is it for this video. I have another one coming up before the auction just to go through all of the items that you can buy on the day. I hope to see you on the live stream on the 19th of October. By the way, the stream will be in 2 halves as YouTube doesn't like very long streams. I'll see you then. Wish me luck.